Yes, good evening everyone. In the last videos, we had a very clear discussion about how we can able to work with these linked list data structures. Okay, right? How you can able to work with these linked. Sir, I request everyone to please be on mute. So while class is going on, please check from your answer. Okay, right. So now what is our requirement is we need to implement double linked list in our today's session. Okay, we have to see how this double linked list is going to work. We need to check, sir. Sir, how we can able to implement that? We will see with the help of a program. And if you see in our last videos for developing single linked list, we used Jupyter Notebook. I'm trying to use one different approach for this double linked list. So I will take a program and see how it is going to work. Sir, here I'm going to take the program like test.py program I will take, which is located in our test folder, test.py. So in this, I will write double linked list program, sir. A single file I want to develop. In that single file, the total double linked list concept will come. Okay. Now let us see how it is going to work. Sir, what is the first thing? We have to create double linked list class. I don't want to work with double linked list directly. I want to create a class. Sir, how to do that? First step, I'm creating DLL. DLL stands for double linked list. Sir, we are creating a new double linked list. So in this double linked list class, I want to take another class called node. Within this class, I am initializing the constructor where it will take the first parameter as a self, second parameter as a data. So third parameter is next. Suppose if next node is not available, then I am giving that as a none. And double linked list, right? One more pointer will be there with name previous. So self dot data will become data and self dot next field will become next and self dot previous field will become previous. Like totally how many data we are initializing? We are initializing three types of data. One is nothing but the original data of the linked list. Second one is a next field. Third one is a previous field. Next field is if you have not given any next field, so my next field is pointing to none, sir. If you are not providing any previous field, your previous field is pointing to none. Like this we have, sir. Because why we need to consider like this? I told already, in the single linked list we will have only one node, one field for storing data, and pointers only one field, which is nothing but next. But if you take double linked list, so we are going to have two pointers. What is the first pointer? So to hold previous value, and this field is used to store previous field, and this pointer is used to store the next field. And here we are going to accommodate the data like this we are going to have. So where three fields will be there, one is pointing to the previous node, another one is pointing to the next node, and one pointer is pointing to the data which we are going to hold. So like this we have total. So how many fields will be there in the double linked list? Three fields. That's why while defining node class, I have taken three pointers. One is nothing but a data, another one is nothing but next. Okay, another one is nothing but next. So another one is nothing but previous, like this. Sir, can you please confirm why we have taken this node class and what is the data inside this node class? Is it clear for you people?
Yes, sir, clear.
Right. Please respond. So inside this double linked list, again I am going to define a constructor, because double linked list object, if you create, compulsory it is going to call the constructor, right? Which things will be there inside the constructor? As usual, so I'm going to define two pointers. One is nothing but head. Initially head is nothing but null. See, in our single linked list, I have not mentioned anywhere tail pointer. Okay, I have not mentioned anywhere tail pointer, but here I am going to take the tail pointer. So tail pointer is going to give the last element in the linked list, but head pointer is going to take the first element in the linked list. Okay, so in our single linked list, we have not taken these two, but in the double linked list, I am trying to take. And one more thing, sir. So self dot, I'm introducing one more variable called count. Sir, what is mean by count? Count is nothing but how many nodes are they existed in our double linked list. We are representing by using this count variable. Okay. What is the purpose of this count? Sir, how many nodes are there in your double linked list? We are representing by using this special pointer called count. So that's why three variables I defined for any double linked list. Sir, I'm creating a new object for double linked list like this. Now, sir, can I call list.count? How many nodes are there, sir? If you run this program at the very beginning, we don't have any elements. That's why the output what we are getting is 0. Later we will see how to get the details, all these things. Sir, in this double linked list class, so can I say this one is nothing but what? Node class. Okay, which defines double linked list, And what about this one, sir? Can I say it is a constructor for double linked list? And what about this one, sir? It is nothing but a constructor for node class. So in this constructor, we are initializing the node related attributes, and in this constructor we are assigning double linked list related attributes. Sir, now my requirement is I want to get a size of the linked list. So size of double linked list. How to get, sir? I will write a function called size. So compulsory, we are going to take self as a first parameter. Why? Because we have taken this size function inside this class DLL, right? So it is inside double linked list class. That's why we are going to declare like this. And this size is going to return which value? Count. Size means what? How many nodes are there in your double linked list? That will be returned by this particular size function. Sir, next I am going to take, so empty function I am going to define. So what is the function name? Empty. I am going to take self, and it is going to return. So self dot count is double equal to 0. Sir, if your self dot count is equal to 0, then what will happen? Sir, it is going to return true. If count is equal to 0, sir, can we say we have 0 number of elements, right? Then isEmpty function is going to return true. Otherwise, isEmpty function is going to return false. Like this, I implemented isEmpty. So isEmpty function is going to return true or false based on the value of size which you have provided, right? Sir, now I will call with this data I want to call. Sir, can I call list dot size? Because it is a function, right? We can call, but unfortunately it will return some value. That's why we are printing inside a print. Similarly, we can call isEmpty also, which is going to return either true or false. But as of now, you can see get a size function is going to return 0 because 0 number of elements are there. And isEmpty function is going to return true because we have how many nodes are there? So 0 number of nodes. That's why it is empty list or not? Yes, that's why it is returning true as the result. Sir, can you please confirm? With this, we covered the double linked list. Just let me copy paste this for checklist. Because what we covered, we need to see. That's why in the checklist, I'm going to take this one. Sir, creation of double linked list class completed. creation of node class completed, size of double linked list, and how this isEmpty function is going to work. So these things I explained very clearly. Can you please confirm, friends? Up to this, do you have any doubts?
No, sir.
No, sir.
No, sir.
Right. Now, please think a bit carefully. I'm going to implement the functions one by one. Highly recommended to please concentrate. Okay. Sir, what is the first function? Is I want to print list. I want to print the print double linked list by using iteration. By using iteration in the sense what? I'm using a loop. I'm using a loop to print these values. Sir, let us see how to define. I'm taking def. So print list iterative like this I'm taking, where the first argument is self. Sir, for displaying the items, we should have a list, right? Consider this is nothing but my double linked list what I have. Okay, consider this is nothing but my double linked list what I have. In this double linked list, how many nodes are there? Consider we have 3 nodes are there. Okay, how many nodes are there, sir? 3 nodes are there. So the first node pointed is always head, right? This first node is always pointed by head. So 10 is the data. Its next field is this one. And this previous field is this one. And its data is 20. Its next field is this one. Its previous field is this one. But unfortunately, I have created one more pointer for this. What is this pointer name? Tail. Consider the data is 30. Like this I have. Now my task is I want to display these elements, sir. I have to write a code to display these elements. How to display? First, we are going to check. Okay, first we are going to check array is a self dot head, because we need to use instance variables. These are instance variables. That's why we are taking self. Is self dot head is equal to none. So if self dot head is equal to none, then I can say my list is empty. I don't have any elements to print. Simply return the control. Sir, now my list is not empty. So take a current node, which is always pointing self dot head. So first node will be always pointed out by this current, sir. Okay. So this will become your current node now. Sir, what we have to do? You need to check whether the node is existed or not. While your current node your current node is not equal to none. Sir, is your current node is equal to none? No, it is not equal to none. Then I am going to print, so current node dot data, comma end is equal to, I need some arrow mark like this I have taken. Sir, after this, current node will become current node dot next. Sir, after coming out from this while loop, I am printing none and return the control. That's all, sir. Now see what will happen. Sir, we are printing current node. What is a current node? Is current node is not equal to none? Yes. Print current node data. What is the current node dot data, friends? 10, right? So 10 will be printed and end is this arrow mark. That arrow mark will be printed. Then you can see one more instruction. Current node is referenced to current node not next. Sir, this is the current node. What is the next node to this? Now this will become your current node, but not this one. Since it is a while loop, again it will check. Boss, your current node is not equal to none. Yes, it is not equal to none. Can you please print its data and put arrow mark? Yes. Then your current node will become current node tends to next. Now this will become your current node. Sir, is your current node is equal to none? No, sir. Then what will happen? Your current node will become current node tends to next. At last, my current node value is nothing but what, sir? None. Then immediately it will stop. Once if the while loop got stopped, so what value we are printing at the end? We are printing none. These are the elements which are present in double linked list. Sir, up to this, we have not covered how to make the links. So because how we are going to construct the links, that construction of links will be there only at the time of inserting a new node and at the time of deleting a node. In the remaining cases, so we are not required to perform these activities. Keep that in mind. In the remaining activities, we are not required to go with this particular what you can call previous field. So at the time of insertion and deletion only, we have to touch those two. Sir, can you please confirm if we have a list like this, how to display the elements one by one? Is it clear for you people?
Yes, sir.
Yes, sir.
No. So of course, it is not going to print right because we don't have any elements in the list. So if you are trying to call print list iterative function, if you are trying to call, so print list iterative function, so by using this list object, what output we are going to get? Simply it is going to throw a message saying my linked list is empty. Now, sir, can you please add some objects so that I can able to understand? Yes, we have functions are there, right? First one, I want to perform insert at a first position or insert at a first location. How to do insert at first location? Sir, we are going to write a function for insert at a first. So keep very clear clarity on this, because if you understand this one, rest of the things will become very easy for you. So I will explain by taking 2 or 3 examples. Please listen carefully. So insert first I am taking. Sir, do we have any elements? What is the first step that we have to do in the insert first? But before moving to the insert first, please make sure. So my head pointer and my tail pointer both are pointing to which location, sir? None, right? Because we don't have any elements. Initially, both are pointing to none. Now, what is the first step? Anyway, we have to create a node. I am taking a node, something like new node. New node is equal to, so I am taking self dot because it is present inside the class. Self dot with the given data. Next field is none. Previous field is none. Oh, we created a new node, sir. We created a new node like this. Listen carefully. We created a new node like this. So what is the previous field, sir? The previous field is none and the next field is also none. So my previous field is none, next field is also none. What is the name of this particular node? It is nothing but new node. What is the content? Assume the content is nothing but 333. Like this, we have created a new node. Okay, fine. I created a new node. Then I am checking. Once if the node is created, can I do this activity? Self dot count is equal to self dot count plus 1. So one node we created, we are incrementing the count of nodes. Then I am checking array. In the self, one head pointer is there. Is it pointing to none? Yes, it is pointing to none. If it is pointing to none, then whatever node that you have created, it will become head, and whatever node that you have created, it will become tail node and return the control, because we don't have any elements. If you don't have any elements, what we are doing? Sir, we are making this particular node as a head node, and we are making this particular node as a tail node. Now we have two references are there. Head is pointing to this 333. So tail is also pointing to this 333. Okay, like this we have. Sir, okay, fine. Now new node got created. It is attached. I want to check. Sir, let us see what will happen. So here I am going to take list dot. So insert at first of 333 I am taking. Now let us execute. Is that 333 got added? Yes. We have one node is there and is empty is going to return false. I will remove this is empty just up to this. You can see we have 333, only one node is there. Sir, now I have a list is there. Now I am trying to insert one more time. One more time I am calling. This time I am going to call the same function by calling insert at first 322. Sir, what will happen? First, immediately the instruction will come here. So we are going to create a new node. Definitely a new node will be created. Okay, a new node will be created. So previous field is pointing to none and the next field is also pointing to none. Okay, so what will be the data? 222 is the data, previous field is none, next field is none. So the name of this node is nothing but what, sir? New node. Sir, do you know this reference is by default deleted? Sir, I created a new node. Okay, fine. Immediately count will become 2. Then I'm going to check if self dot head is equal to none. Sir, is head is pointing to none? No, sir, head is not pointing to none. Then immediately what will happen? If is going to be failed. Once if the condition is failed, we have a list. Whatever the new node which you are creating, that you need to bring to the beginning. Means technically this node should come where, sir? Here only, right? So now we have to write code for establishing the links. How you have to establish the links? We have to write code for that. What is the first link I am checking? So self dot head is there, right? Its previous node is pointing to new node. Sir, self dot previous, sorry, self dot head. This is the self dot head. Its previous node is pointing to, this previous node is pointing to this particular node. Clear, right? Sir, now what is the next one? We have to point next node also, right? So your newly created node is there, right? Its next field is pointing to self dot head. Sir, this is the newly created node. Its next field is pointing to self dot head. Oh, our links got established successfully. Now what we have to do? Sir, the node whatever you created will become a new node or not? Yes. Then I mean head node or not? Yes. Self dot head will become new node and then return the control. So what will happen? Now this entire pointer is going to be deleted and this head is pointing to this particular node now onwards. Okay, I think friends, you people got a very clear idea. So how you can able to add a node at the beginning. Now let us cross check, is it really added that 222 or not? Sir, is the 222 got added or not? Yes. Now I want to add 311, same process only, right? Now you can see that 311 got added at the beginning. So this is the code, sir, how we can able to add a node at the first location. Please confirm everyone, is the concept is clear?
Yes, sir. Sir, can you explain one more? Self dot head dot previous. This logic.
Self dot
Head
head
dot
dot
previous
previous.
is equal to
See
new node. Yeah.
here self dot head indicates this particular node initially 333. Okay, so it's a
Yes, sir.
previous node, it's a previous link. Previous link means what? This one, sir. This one is nothing but a previous. This I am attaching to new node. So this link is very new for you. This link name is nothing but a previous. This link name is nothing but next. So your newly created node next field will become 333 and 333 previous field will become new node. After that you have to make head as a new node. Got it?
Yes, sir. Yes, sir.
Right. So this is nothing but what we have, sir. Now, sir, what is the next algorithm that we have to? 1 second. So what is the next algorithm that we have to discuss? Sir, my linked list is ready, but I don't want to add at the beginning. My requirement is I want to add at the ending. Sir, in the previous cases, we struggled like anything to move to the ending. But here we are not required to do any activity. So insert at last location will become very easy because so insert at last. So I am taking self comma data and the first few instructions are same. First we are creating a new node with the given data and the next field is none, previous field is none, and self dot count will become, okay, self dot count will become self dot count plus 1. Then what we are checking, if self dot head is equal to none, if there is no more elements, so your self dot head will become so newly created node and your self dot tail will become newly created node and then we have to return the control up to this common, sir. But sir, my list is already available. Now I want to create a new node. Sir, where the new node is going to be added at the last, I know that. And here I'm going to take a link like this. So where previous node and the next pointers will be there. Consider the data is 999 and the name of this node is what? New node. Now we have to attach this new node as a last. Sir, very simple. How to do that? First, you need to write your new node is there, right? Its previous field will become your self dot tail, sir. Sir, this is your new node, right? It's a previous field I am taking self dot tail. That means tail node will become its previous. Okay, fine. Then what about the next one, sir? So the next node we have to attach. So self dot tail is there, right? Its next node will become your newly created node. So self dot tail, this one next node is nothing but this one. Oh, I established the connections. So anyway, this last field already came with none, right? We are not required to reallocate. This tail we have to move to the new node, right? Whatever newly created node is there, so that will become your tail now, because it is not required to write code for traversing, because first node is always pointed by head, last node is always pointed by tail, so that easy to insert at the beginning and ending. Okay, so this is the way how you can able to do. Let me cross check. Already we have 333 322 is there, right? Now I want to insert. Okay, I want to insert 777. Where I want to insert? So insert at last function I am taking. Now try to run this code. Is it going to insert the data at last or not? Let us cross check. You can see 777 got added at the ending. Sir, I want to add 888. I want to add 888. Let me cross check. I want to add 999. Let me cross check. Is these values are added or not? Yes. Sir, this is the way how we can able to perform insertion from the beginning and insertion from the ending. So with this print list display function with iteration and insert first, insert last. These operations are clear for you people, I think so. Can you please confirm, guys? Do you have any doubts up to this?
No, sir.
Please confirm any doubts up to this.
Yes, sir. Clear.
Right. Yes. So practice up to this, sir. Today I am stopping the session. Tomorrow we will continue with this. Okay. So tomorrow we
Yes.
are going to see the continuation of these remaining operations. I request everyone to please practice parallelly, sir. Otherwise, it is difficult for you to understand. I'm copy pasting the code in the running notes. Just practice this. Okay. Right. See you tomorrow, sir.
Thank you, sir. Thank you, sir.
Thank you.